So guys, welcome to aircraft structures class. So those who are facing issue in recording, I am planning to upload these thin world classes in YouTube one by one, so they can refer there. Okay. So now we will derive the formula, okay, for unsymmetrical bending. So it is direct stress or normal stress, okay, so due to unsymmetrical bending. Okay, so we will take the cross section, same cross section, and in that cross section this is the area on which we are finding bending. So this area is at some distance y dash, okay, perpendicular distance, and from neutral axis. This is your neutral axis, guys. This is your neutral axis, okay. And these are my coordinate, xy coordinate. This is x and y coordinate system, okay. In this xy coordinate system, you can see x is the distance from vertical axis and y is the distance from horizontal axis, okay. These are my distances, okay. Now you all know, right, moment direction. So we have two moments, mx and my. These are producing tension on this element, right? That's why we have shown this moment direction like this. And we know these moments will produce, these moments will produce tension on these elements, right? Yes or no? In last class we discussed yes or no, right? To produce tension here, my moments would be like this and this, right? And these moments follow each other, okay. Now guys, we know from transformation, displacement transformation, we consider this angle alpha. This alpha is what? The angle made by neutral axis. So this is our neutral axis. We consider this x dash y dash is your x dash is your neutral axis. This is my neutral axis, okay. Now guys, I want to write this y dash in terms of x and y. So you guys have learnt in vector, yes or no? What will be y dash? Y dash will be x sin alpha plus y cos alpha from transformation. How many of you know this? How many of you know this vector transformation? Anybody knows? My y dash will be x sin alpha plus y cos alpha. Anybody knows this? No? Okay, those who are not knowing that, they can go back and refer. I will share the reference also. The transformation of displacements, how it is done using vector. Okay, you guys can go back and refer. Here in simple way I will explain. See guys, it is like this, okay. So this is your x and this is my y and this is my y dash and this is what your x dash and this is alpha angle, okay. Now guys, I want y dash in terms of x and y. So if this angle is alpha, this is will be alpha. Now if you resolve this x component along y dash, what it will be? What will be? X component along y dash, what it will be? Bhavyashri. It will be x sine alpha, right? Now, what is this y component along y dash? What is the y component along y dash? It is y cos alpha. Okay, so this is how you can in simple way understand this transformation. Otherwise there is a transformation matrix, there is a transformation matrix like stress transformation is there, right? There is a transformation matrix, okay, displacement transformation matrix, you guys can refer. Now what will be x dash? Can anyone tell what will be x dash? What will be x dash? Anybody, what will be x dash? What will be x dash? It will be x cos of alpha minus y sin alpha. Yes, Vikas, good. Not plus Mr. Alvar. See, if you resolve y along this x dash direction, it will be in opposite direction. So it is minus y sin alpha. So if you write your transformation matrix x dash and y dash, what will be your transformation matrix? It will be what? It will be cos alpha minus sin alpha, then sin alpha, and then cos alpha. This is multiplied by y, what? X and y. Clear? Is this clear, guys? Yes or no? Everybody, is it clear? Okay. Now guys, we need y dash distance, right? Why we need y dash distance, guys? Why we need y dash distance? Anybody know? This is the distance from neutral axis, right? This is the distance from neutral axis on the element where we are finding bending stress. Now guys, once you know all these, right? Once you know all these, once you know all these, you know what is the relation between strain and strain and curvature? What is the relation between strain and curvature? What is the relation between strain and curvature? We know, right? The strain is what? Curvature times perpendicular distance, right? Curvature time perpendicular distance. Curvature is nothing but what? 1 by r, radius of curvature. You can say y dash by capital R. Now we can substitute, guys. What is your stress from Hooke's law? Sigma equal to modulus of elasticity times epsilon, right? So you can see this, and sigma is in which direction? Sigma z direction. Okay, so sigma z equal to E times epsilon. Now substitute here the values. Epsilon is what? Y dash. So y dash is what? X sin alpha plus y cos of alpha is what? Sigma z. Now guys, this is equation where what are unknown here? What are unknown, guys, here? In this equation, if you check, my unknown is what? Sin alpha and cos alpha. So I will substitute my sin alpha and cos alpha in terms of moment and inertias. How we can do? So first, what is the stress resultant? You know, right, guys? There are two stress resultant. One is force resultant and one is moment resultant. Force resultant is what? Suppose on some area there is some bending stress, right? You know, usually bending stress variation from simple bending. So this is sigma. So if you integrate this sigma into area, What you find? What is the first moment of sigma into integration sigma dA is what? 0. Why 0? First, why it is 0? That we are not applying any horizontal force, right? There is no force in axial direction. So when you integrate force, okay, elemental force, total force is 0. Okay. Now what is sigma? Sigma is further, you can write it is E into epsilon dA, and further what is the epsilon? It is E into y dash by r dA. Now guys, we already know from here E and r is constant. So what we found? Integration y dash dA equal to 0. So that means what? The first moment of area about centroid is 0, right? So this is what your equation from force resultant. Integration y dash dA equal to 0, that we know, right? And we found this means what? Your neutral axis passes through centroid, because this is known for what? Centroid. Okay, so that means your neutral axis passes through centroid of the cross section. Now guys, moment resultant. So in case of moment resultant, guys, what is the moment resultant? If you multiply the sigma dA, right, there are two moments, right, mx and my. So if you multiply this force, elemental force, by moment arm, so moment arm, there are moment arm about what? X axis as well as y axis, right? This was your element. Anyway, let me draw unsymmetrical section, not symmetric. Okay, and this is what your centroid. So this is x, this is y. Now guys, if you find mx, what is your moment arm will be? This will be moment arm, right? Because this force is what? Sigma dA. So sigma dA into this moment arm y. Okay, if you integrate this, so what you get? Mx. Okay, now same way, this sigma dA into momentum, this x, if you integrate, what you get? You get my, and this is what? Mx. Okay, so you can see this mx and my. Now guys, in this mx and my, we can substitute with this value of sigma z here and here from this equation. When you substitute these values, guys, when you substitute these values, you can see your mx will be what? E by r sine alpha integration xy dA, xy dA plus cos alpha integration y square dA. Now guys, what is this? This is nothing but what? Can anyone tell? What is this? Integration y square dA is what? It is ixx, exactly. And what is the integration xy dA? It is ixy, right? So that means this equation, you can see here what it is. It is E by r, which is constant, I can take out, then sine alpha into ixy plus cos alpha into ixx. Same way, this is what? Mx. What will be your my? It will be E by r, E by r. Now guys, what will be your E by r? Then you substitute, what you will get? You will get sine alpha, then I y, right? Am I correct? I, yes or no? You get? Then plus cos of alpha, what you get? Ixy. Yes or no? Now guys, what I can do, I can write this mx, and my in matrix form. If you write this mx and my in matrix form, what do you get, guys? If you write in matrix form, what you get? Mx my equal to E by R, then Ixx, Ixy, then Ixy, Iyy. This will be multiplied by what? Cos of alpha, sin of alpha. Clear, guys? Now this cos alpha and sin alpha, how can I find, guys? By matrix inversion, right? So you can find here cos alpha and sin alpha by what? You can write R by E, then inverse of this matrix. What will be the inverse of this matrix? Can anyone tell? What will be the inverse of this matrix? Anybody? What will be the inverse of this matrix? You all have done linear algebra, right? Yes, it is Iyy minus Ixy minus Ixy and then Ixx, not Izz. Sil. Okay, others please check this. Is it correct? So it is what? Iyy. Okay, Iyy, then Iyy minus Ixy minus Ixy and Ixx, and this is what? Multiplied by what? Mx and my. Right, guys? Now from this, guys, I can find cos alpha and sin alpha and substitute in this equation, which is your bending stress. When we substitute cos alpha and sin alpha, what we get, guys? Substitute, guys. You get this equation, right? Finally, when we substitute, we get this equation. Okay? So guys, one more thing. Here when we take inverse, when we took inverse, there will be one term right here. You are missing that, Mr. Sahil. When you take inverse, there will be here term. What it will be? It will be Ixx into Iyy minus Ixy square. Determinant. Okay, so when you substitute determinant, and so from here you can find first cos alpha and sin alpha. So you can see this is what my cos alpha, which is R upon E Ixx minus Ixy square, then Iyy mx minus Ixy my, and sin alpha is what? R by E into Ixx Iyy minus Ixy square into minus Ixy mx plus Ixx my. Now guys, sin alpha, cos alpha, you know, you substitute, right? And this formula I have written, right? Without knowing this, how I have written, guys? I told the trick how you can write. What is your sigma z? So what will be? 1 will be x and another will be y, right? So when it is x, what will be? You will have the moment my, then multiplied by ixx, then minus mx into ixy, okay, by ixx into iyy minus ixy square. This is what determinant. Then here plus sign it is y. So y means what? It should come mx, then iyy minus my into ixy upon ixx iyy minus ixy square. Guys, can you remember this formula by this way? Can you guys remember this formula by this way? Anyway, determinant everybody remember. The only trick x, then moment will come my. My means multiplied by ixx, then minus sign is there. Then minus mx into ixy, same way. Y means mx into iyy. Guys, can you remember this formula? Even if you don't know derivation. See, derivation they may ask in your engineering semester exam. Yes or no? If you write aircraft structures in engineering semester, they may ask derivation, yes or no, right? But in GATE, they are not going to ask any time derivation, right? You must know this formula. Now, how we can check this formula, guys? How we can check this formula? If your cross section is symmetric, if your cross section is symmetric, then what is the condition, guys? For symmetric cross section, even single symmetry. What is the symmetric cross section condition? Symmetric means your ixy product moment of inertia is what? 0. Okay, so that means if you substitute this 0 and this 0 and here 0, here 0, what you guys get? This ixx will get cancelled. This iyy will get cancelled. So your sigma z will come as what? My upon iyy into x plus mx upon ixx into y. Am I correct? So this is what we know, right? For what? Complex bending or compound bending, right? We have discussed this, yes or no, guys? Now once you know this, further for simple bending, this is what above equation is for what? Complex or compound bending, right? Now guys, further for simple bending, guys, what is the condition for simple bending? In case of simple bending, either what is the condition? Either my is 0 or mx is 0, right? Either mx or my is 0. Usually what is 0? Usually what is 0, guys? Can anyone tell in simple bending? What is 0? Usually what is 0? Usually, guys, what is 0? My is usually 0 in simple bending. Okay, so that means in case of simple bending, your formula sigma z is what? It is mx upon ixx into y. This formula is nothing but, guys, what you all know, right? Sigma equal to m upon I into y. Now, guys, you all know this formula, right? Blindly. You all know, right? This formula, guys, blindly. Yes or no? Sigma equal to m upon I into y. But what is the actual formula? The actual formula is this. You should know what is that moment. Either it is mx or my, or what is your inertia, ixx or iyy. Clear? Yes or no, guys? And these inertias will be, or these moments will be, how your load is applied. Based on that, we discuss. Now, guys, in that equation which we have already derived, right? So in this equation, this is known as what? This quantity is known as what? Usually we write it as a k1, okay? And this second term, it is k2. So you guys can see further, k1 is what? It is ixx into my minus ixy mx upon ixx iyy minus ixy square. K2 is what? Iyy minus mx minus ixy my upon ixx minus ixy square. So final, your bending stress formula for unsymmetrical bending is what? It is k1x plus k2y. Can you guys remember this formula? Yes or no? You all can remember, right? And what is your K1 and K2? My K1, see, I am telling guys, this is one of the most important formula when you go and work in aerostructure industry. Okay, either you work for Airbus, Boeing in aerostructure, or you work for UTC Aerospace Systems, or in engine company. It is not that important, because in engine we use thick structure, thin wall we don't use, but mainly in airframe, wing components, okay, all these are very important. Yes, guys. Yeah, complex bending. See, it's a bending, Ravi. When it is known as complex, if it is your cross section is symmetric and both the you have moment about both x and y. It's basically bending. Unsymmetrical bending word we are using when your cross section is unsymmetric. If your cross section is symmetric and then you have moment in inclined plane, then it will have both component, right? Mx and my, then your bending will be complex. So again, what is your k1? It is my ixx minus mx ixy upon ixx iyy minus ixy square, and k2, because in aerostructure bending is predominant, right? Which is one of the most important loading. In wing, what is the most important loading? Bending is one of the most important loading, right? I will have a lot of bending load, right? That's why spar is used. Okay, so everywhere this formula come in picture when you go for aerostructure analysis. They ask Rutvik, right, to derive bending. Yes, because it's unsymmetrical bending. They will ask flexural shear flow also. Even once I went for Airbus interview, they asked me draw shear flow for yeah. Yeah, that is their business. Okay, and sometimes they will just to make college happy. That is different thing, Rutvik. But if you go in a company like Airbus, Boeing, yeah, UTC is known as Collins. Yes, Sivendra Raj, but UTC is known for which component? Can anybody tell? I have given that session. What all the component-wise companies in India or across the globe? So UTC mainly work, or Collins Aerospace work in which domain in aero? For which all component in aerospace domain? Anybody? Yeah, one more thing I want to tell guys. UTC Aerospace System or Collins Aerospace System hire every year graduate engineers trainee through off campus. Anybody know? In UTC they put on their website job position called graduate engineer trainee. For that they take written exam and then they take interview. So guys, and every year they are hiring people in Bangalore, I know. Okay, some of our students also got. So can anyone tell now? Collins Aerospace work for which all components? Have you guys heard about earlier days Goodrich Aerospace? Goodrich Aerospace. What is the Goodrich Aerospace, guys? Huh? Anybody knows Goodrich Aerospace? See, Goodrich Aerospace was one of the landing gear company. Okay, Goodrich Aerospace was one of the landing gear company that got merged with what? UTC. Okay, so it became UTC Aerospace System. UTC was famous for what? UTC was famous for Nacelle. Okay, so UTC and Goodrich got merged, then it became UTC Aerospace System. So UTC Aerospace System was working for what? Nacelle and landing gear. Then what further happened? This UTC Aerospace Systems and Rockwell Collins got merged. Then it became Collins Aerospace. What Rockwell Collins was doing, guys? Rockwell Collins, anyone knows why it is famous for? Rockwell Collins? No, Rockwell Collins is known for interior. No, interior also do interior, but not much. Interior, I will tell which all company interior. Rockwell Collins was mainly famous for avionics. Which two most predominant dominant companies in world for avionics? No, avionics is what? Which all company? Honeywell, Rockwell Collins, and one more company is there. Can anyone name for avionics? Which is the third company? The France based. Like this, many are there, but one more. Safran Group company is there. Sejam. Okay. So Snakma is a engine company. Sejam is a avionics company. Okay, in Safran Group. So mainly from US, Honeywell and Rockwell Collins, they lead in avionics, and then France, Sejam is one of the company. Okay. Now guys, we nacelle. So mainly nacelle is most of the aircraft nacelle is provided by UTC Aerospace System, as well as Bombardier Aerospace in Ireland. They also work for nacelle. Okay, Bombardier Aerospace. Okay, in Ireland subsidiary. Okay. Now guys, further in landing gear system. In landing gear, can you guys tell the other than UTC Aerospace System, other company in landing gear? Landing gear, any company other than this Collins Aerospace? You guys should know, guys, which all company there component wise, okay, in the world. There is something called Mosier Bugatti. Have you guys heard about Mosier Bugatti? They are car in car industry also there. Mosier Bugatti. Okay, they are famous for landing gear and they are part of Safran. That is Safran Group company. Mosier Bugatti. Okay, I am not sure. Okay, so you guys can search in Google later. Okay. Anyway, in my that session I have given. So like that, there are different companies, right? See, in aerospace world, single company don't do everything. Even if you use Airbus aircraft, the engine is by what? Engine either by General Aviation, GE, or sometimes you guys know, right? There is a partnership between GE and Safran also. G and Safran also partner. There is some engine series called CFM. How many of you have heard about CFM engine? Yeah, Rolls-Royce also make. Pratt& Whitney also make engines. Even, but mainly Rolls-Royce and G and Safran engine are used most. There is a CFM engine. Every single aircraft which fly uses CFM engine. Every second aircraft, people tell every second civil aircraft which flies uses CFM engine earlier days. Now CFM engine is again Gen X. There is a new engine Gen X. G and Safran engine Gen X. Okay, now this is replaced by Gen X engine series. Okay, so that is not G engine or Safran, it's a CFM International. They have the partnership on that. Okay guys, so all these things you guys can explore on your own, because in aerospace world, if you go for government job, then you should know what all product, what all work government sector doing in India. If you work in private MNCs in a particular domain, you should know that about products and companies. Okay, fine. So now let's comes back to this part, unsymmetrical bending. Yeah, complex and symmetrical bending. So guys, when your cross section is what? If your cross section is what? Symmetric. What is going to happen for symmetric cross section? Vignesh, your IXY is what? 0. Right? When your IXY is 0, your bending will be what? It will be complex or compound bending. Okay? Clear? So what is that formula? Complex or compound bending? It is what? My upon Iyy x plus mx upon Ixx into y. Okay. Now guys, here in simple bending, usually what? My is 0, right? So that means your sigma z is what? Mx upon Ixxy. What is this case? Usually you all know, right? We use rectangular or square cross section beam, and it is x and this is y. So you know, right? Your bending moment is applied usually about what? Usually about x axis, and right, and you will have load in y direction, right? So that's why you can see this is mx upon Ixx into y. Just a moment, guys. Okay, so guys, clear till this? Yes or no? Now guys, already I have discussed this is compound bending or simple bending. Here one thing I want to draw. Last class I was drawing both the moment in the same figure. But now I just want to show you guys graphically. So first I have what? I have the moment which is mx is applied. So this is my cross section, guys. This is x and y. Now you have moment which is what? Mx. Okay, mx is applied. So how it will be applied, guys? If you see graphically, okay. So positive means here, then it will be applied like this. You guys are able to understand? So where we how it will be deformed? If you see the deformed shape, on top it will be tension, okay, and bottom it will be what? Compression. Yes or no? This is clear? Yes or no, guys? So from your sense it is what? It's a sagging moment, hogging moment, right? Okay, in our sense it is a hogging moment, but how we decide this moment direction? Not based on sagging and hogging. We decide here it should create tension. When complex bending is unsymmetrical, if your cross section is unsymmetrical, Bhagyashri, it's a reverse way. If your ixy is not 0, then you will have unsymmetrical bending. Clear? If your ixy is not 0, then it is a unsymmetrical bending. Clear? Now guys, second case. In second case, guys, again you same beam at the same instances, the same beam at the same instances, you have what? Your cross section same, and you apply what, guys? Moment about y axis. So that means this is the moment my. So how it will be? It will be like this, right? Are you guys able to visualize? Yes or no? So that means what? Your bending will be like this. This is bending about what? Y axis. So here what? In this part again you have a tension. Yes, only cross section makes your bending unsymmetrical. Okay, it's only cross section, not load. Okay, if load is not at symmetry, what it is going to do, Ravi Teja? See, your load is not applied through centroid. What is going to do? It will create additional couple, right? Nothing else. So additional couple means it can have additional bending or it can have a torsion. Okay, so if your cross section is unsymmetrical, then only you will have unsymmetrical bending. Now you guys are understanding this part? Yes or no, guys? In complex bending, it is what? Superimposition. This plus this, somebody was telling na, we can superimpose. Yes, we can superimpose two simple bending, it will become a complex bending. Yes or no? So what is this? What is this case in terms of simple bending? Sigma z equal to mx upon ixx into y. What is this case? This is sigma z. It is what? My upon I y into x. Now this plus this is what? Your this. Yes or no? Everybody? Is it clear? Shivani, Agam, Akash, Kunal, are you clear? Shubham, Shubham, Sri Krishna, Sri Harsha. Vikash, Vishwaraj. Okay. Now guys, you all understood what is simple bending, right? So you can understand simple bending can be due to mx alone or it can be due to my alone also. And you guys know, right? In case about if your moment is about my 0, this is your simple bending. If your moment is 0 about mx, then this is, so this is what your simple bending. That's it. Now the next is what? Neutral axis. So about neutral axis, you all know, right? We need to find the position of neutral axis. So about neutral axis, what is the clarity? What is your bending stress about neutral axis? What is your bending stress about neutral axis? It's a 0, right? Right? It is 0. So we know formula sigma z is what? K1x plus K2y, and about neutral x is 0. So that means what? This K1 into xNA plus K2 into YNA equal to 0, right? So 0 equal to what? K1 into xNA, because you are writing your bending stress at neutral axis. That's why I have written coordinate xNA and YNA. So K2 YNA. Now guys, from this equation, if I write minus YNA upon XNA, how much I get? I will get it as what? K1 by K2. Yes or no? Is this clear? Minus YNA upon XNA from this equation is what? K1 by K2. Now you guys see this. This is what we have seen initially, cross section, right? In the cross section, while deriving unsymmetrical bending, we consider this is what? Your neutral axis NA, and NA making alpha angle from horizontal axis. In what? Clockwise or anti-clockwise? This alpha is measured in clockwise or anti-clockwise. You can say it is a clockwise angle. So in this equation, suppose this is the point where I am considering this coordinate. So what is the coordinate of this point? What is the coordinate of this point? It is XNA, comma, can anybody tell? Plus YNA or minus YNA? What is the coordinate of this? Plus YNA or minus YNA? It's a minus YNA. Minus YN. Now guys, I am considering this triangle. I am considering this triangle. This is alpha. This is minus YNA, and this is what? Plus XNA. Now what is the tan alpha guys in this triangle? What is the tan alpha? It is minus YNA upon XNA. So that means it is what? It is K1 by. Clear? So what is your alpha? Alpha is tan inverse. It is tan inverse K1 by K2. What is alpha? Tan inverse K1 by. Clear guys? Is this clear? Now alpha is measured in which direction? Alpha is positive and it is measured in what? Clockwise from X. Okay, clear? So guys, if you refer Maxon book, why this minus sign is coming, they are not clear. They are not clarified. You guys understand why this minus sign exists? Because you are taking a point which is on what? Negative y axis, right? Is this clear? The position of neutral axis, guys, alpha is tan inverse K1 by K2, and how it has come? Everybody, is it clear? This part is not clearly mentioned in Maxon book. Okay? So once you know this, I can write this K1 and K2, right? In terms of what? Moment and inertia. I can write in terms of moment and inertia. So tan alpha, right? So what is the K1? Anyway, numerator will come, denominator will get cancelled, right? So what is the K1? It is My. What is the K1, guys? It is My into Ixx minus Mx into Ixy. Denominator will get cancelled. So only numerator for K2. What is the numerator? It is Mx Iyy minus My Ixy. So this is the formula for tan alpha. Everybody, is it clear? Tan alpha formula. So this is tan alpha formula. Now guys, further for complex bending, guys, what is the Ixy? For complex bending, what is your Ixy? Hmm? For complex bending, Ixy is 0, or for simple bending, Ixy is 0. So when Ixy is 0 for complex bending, what will be tan alpha? Can anybody tell? Tan alpha will be what, guys? It will be My into Ixx upon Mx into Iy. Okay. Now guys, for simple bending, there are two simple bending, right? The first, I will take the first case. Case 1, simple bending, right? You have simple bending about x-axis, mx alone. My is 0. So what is tan alpha? Right? 0. So what is neutral axis? For case 1, mx alone. So what is tan alpha? So what is alpha? 0. So what is your neutral axis, guys? In simple bending, what is your neutral axis? Your x-axis is neutral axis, right? That's why you guys know, right? You take, this is neutral axis. Now you all understood why x-axis is neutral axis for simple bending? Clear na, guys? So any point on this neutral axis, we know, right? What is the bending stress at any point here? We all know, right? Your bending stress is 0. Okay. Now case 2. In case 2, guys, your case 2, what is the case 2? You have My, right? Your Mx is 0. So what is the tan alpha? Your tan alpha will be 90 degree. Tan 90, right? Tan alpha is tan 90, right? Infinity. Tan alpha is how much coming? Infinity. So infinity means what? Tan 90. So alpha is how much? Alpha is 90 degree, right? Now guys, we all know, right? The bending happens about which axis? When my alone. This is your y-axis is neutral axis, right? That is what we have seen in the picture. I have drawn now that picture. Here you guys can see, right? In this picture, you all know, right? This is what your neutral axis. I'll draw with orange color. This is your neutral axis. And in this case, what? This is your neutral axis. Yes or no? So now you guys can see you are in line mathematically as well as graphically, right? Physically and mathematically you are getting the same thing. Yes or no, guys? Mathematically as well as physically, both are in line. Yes or no? Everybody, it is clear? Why neutral axis is important, guys? Because your bending always happens about neutral axis. Okay, guys, in case of complex bending, which is the axis where your stresses are zero? In a cross section, for a complex bending in cross section, which is the axis about which your bending stresses are zero? I am talking about in complex bending, guys. Which is the axis? Is it x axis or y axis? What I am telling, guys, suppose I have a beam, okay, and it is a rectangular cross section. Now it is subjected to a complex bending, okay, it is subjected to a complex bending. Tell me, guys, which axis will be in this cross section about which your bending stress are zero? Eh? There will be an axis about x axis in complex bending, stresses will be zero. Side. Think and tell. This is mx. So my bending stresses will zero in case of complex bending or any simple bending, always about neutral axis. And here we know neutral axis makes some angle alpha. Okay, so on this neutral axis your bending stresses will be zero. Okay, so one side of neutral axis where your bending stresses will be maximum and then minimum, it depends on the distance. Clear? Where your bending stress will be maximum, it will be maximum from what? Furthest aft point from neutral axis. Where the bending stress will be maximum? Where bending stress is maximum, guys? Sigma max. Where? Furthest aft point from neutral axis, right? No, it is not diagonal, Mr. Savendra Raj. If your neutral axis is 45 degree, then only diagonal. It is not necessary your neutral axis is 45 degree, Shivendra Raj. So your the sigma max is always at furthest aft point from neutral axis. The diagonal is the only case when alpha is 45 degree. So that means your cross section is square cross section and your angle about which your moment is acting 45 degree. Okay, it is not you might have solved that pyq and you might have mug up. Okay, diagonal will be the maximum. That is only if your cross section is a square cross section and your mx equal to my, then there is a possibility your diagonal point where your bending stress will be max. Okay, clear guys? All these points are clear. So every concepts I have made it clear for unsymmetrical bending. Now we will solve PYQs. Any doubt guys? Till now any doubt? Yes or no? So guys, if you go in industry, mainly private industry, everywhere people will ask you questions from this part. Okay, for any job, if you go for Collins Aerospace, if you go for Airbus, you go for Boeing in aerostructure, they will. Sir, in simple bending, where bending stress is maximum? Again, from furthest aft point from neutral axis. What is the furthest aft point? It is the top or bottom, right? Bhavyashri, you know this, right? Where bending stress is maximum in simple bending? It is at top or bottom, right? Because these points are at what? Maximum distance, right? Okay, yeah. So guys, let's move to the question part. Read the first question, what they asked. An idealized thin-walled cross-section of a beam and the respective areas of the booms are as shown. A bending moment My is acting on the cross-section. The ratio of the magnitude of normal stress in the top, bottom to the from top booms to that of bottom booms. So what they asked, they asked these are the top booms, okay, and this is the bottom boom. So they asked what in this case, they asked the ratio of this, the ratio of sigma x top upon sigma x bottom. Now guys, can anybody tell why I took bending stress as sigma x? Why not sigma z? Mr. Amit, why took I sigma x here? Given cross section is YZ, right? The cross section is given in ZY plane or YZ. That's why my bending stress will act in X direction. Okay. So guys, be clear. It's not necessary always you keep writing Mr. Amit sigma Z, right? Bending stress doesn't mean always sigma Z. It is a normal stress, right, to the cross section. Now we have to check which axis is normal. So in this given case, X is my normal axis. Clear? Pratimol, Ravi Teja, Punya, Rishika, is it clear? Kunal, are you understanding what we are discussing? Yeah, non-aero. Suan, Suam, Shuam, are you getting what we are discussing? Okay, good guys, good. Okay, now guys, here, this is clear what is asked. Forget now, for time being, we will not go in this. Now let's see what is given further. Look here. So they have given this. Now tell me guys, is it symmetric cross section or unsymmetric? Is it symmetric or unsymmetric? The given cross section is unsymmetric, Mr. No. It's a symmetric about what? You can see. It's a symmetric about z axis. How it is y axis, Ravi Teja? Think. The given cross section is symmetry about vertical. It's a symmetry about vertical. Right? It's a symmetry about vertical axis. Okay. So that means your ixy is 0. So when ixy is 0, right, and what is your moment given? Given moment here, what is your mz? What is your mz? Mz is 0, right? So that means what? It's a simple bending, right? It's a simple bending. So that means what? Your sigma x will be what, guys? Your sigma x will be what? Your my upon I yy into z. Now what is this z distance, guys? From where this z will be measured? Anybody tell? From where this z will be measured? Will this measured from O origin? From where this z will be measured? This will be measured from neutral axis. Now where is neutral axis for this? Z is measured from centroid, right? Because neutral axis passes through centroid. Now guys, is this given O origin is your neutral centroid? Guys, tell me this. So what is they asked? They asked the sigma x top by sigma x bottom. Now guys, what it will be? What is this sigma x top upon sigma x bottom? That is they asked. Are these going to change? Are these going to change? You find stress at any point. Are these going to change? For any value of z, are these going to change? No, right? So what is actually they asked? They asked z top upon z bottom. So what is required in this case to find? Can anyone tell? What is the unknown which you guys need to find? You need to find the centroid position. Exactly. What is the unknown? It's a centroid. So guys, find out centroid for this. How we can find centroid? You all know, right? So start finding centroid. Right? So centroid. So I am considering my reference is what? O is my reference. O is my reference. And which centroid position you guys have to find? Can anyone tell? O is my reference. Which centroidal position you have to find? X or Z? Sorry, Y or Z? Huh? Ravi Teja, Y? Why you want Y position? It's a Z position, right? Because you need Z top upon Z bottom, right? So that means this Z top and Z bottom should be measured from centroid. So you need Z position. So how Z position you find? So what will be your Z bar? It will be sigma A area of the boom, right? We know that sigma AI Zi upon sigma AI, right? Now guys, there are different booms. So this one boom, two boom, three boom. So on top boom, what is the area? 0.2. First boom, and there are two booms on the top, right? So I can multiply 2 into 0.2, the same area. What is the position from O? 2 centimeter, right? So I can multiply 2. Then middle boom. What is the area for middle boom? It is 0.1. Okay, one boom only. And what is the distance? 2. Then what about this middle boom? What is the middle boom? What is the area? 0.2. What is the distance from O for middle boom? What is the distance, guys? What is the distance for middle boom? Generally, what people do mistake, they will neglect it. Okay, it is not neglected. Only thing here, what distance is 0. Now the bottom boom. What is the area? 0.2. What is the distance? What is the distance for bottom boom? Plus 2 or minus 2? From O, what is the distance, guys? It is minus 2. So it is minus 2. Upon. Now total areas. What is total area, guys? So it is 3 into 0.2 or 4. Not 3. It is how much? How much bigger booms? एक दो तीन चार, 4, 1 2 3 4. So there are 4 bigger booms. So 4 into 0.2, then plus 1 small boom. Okay. So guys, find out this value Z bar from O. It can be plus, it can be minus. So how much value this is coming Z bar? It is coming 2 by 3. Abhishek, it is 2 by 3. Others, please check. Is it 2 by 3? Not 3, 4 na. Shivendra Raj, again you are doing mistake. At O also there is a area lumped mass is there na. At O also. Why 3? It is 4. That's what the mistake people do. You can see na. 0.2 into 0. So there are 4 na. 2 on bottom, 1 on middle and 1 on bottom. So it is 2 by 3, right? Everybody got Z bar is 2 by 3. So that means, where is your centroid? Your centroid is somewhere here, right? Yes or no, guys? So that means this is your centroid. So what will be Z top? This will be Z top and this will be Z bottom. Yes or no? Yes or no, guys? So that means your sigma x, and they ask what? The ratio of magnitude. They also ask what? They ask ratio of magnitude. So that means what? Sigma x top upon sigma x bottom magnitude is what? Now distances from centroid. So what is the distance from centroid? For top boom, it is 2 minus 2 by 3 upon what is the distance? Bottom. So it will be minus 2 minus 2 by 3. Is it clear? See, any value below centroid, what it is, positive or negative? It's a minus 2 by 3, right? Because from O the position is 2 by 3. So it is minus 2 minus 2 by 3. So what is the answer? Minus 1 by 2 is the answer. 5 by 11 is the answer. So was this question tough? Finding centroid, is it tough? Huh? This gate question, was it tough? Guys, many people do mistake. Even some, so-called author books are there na, in market. They are giving one as an answer. People are giving one as an answer. Okay, the internet keys are giving, because official keys are not available before 2011. So they are giving one as answer, which is wrong. The answer is 5 by 11. If they are giving one as answer, they don't understand it. In other coaching also one is answer. That means they don't understand bending, right, Mr. Amit? If one is the answer, means they don't understand bending. I will tell. It is a very simple problem. Okay. Yeah, I'll repeat, Vignesh. So what is the answer? 5 by 11. No, not 1 by 2. Wrong. Yeah, if 1 by 2. So guys, check out. 1 by 2 you are getting means somewhere mistakes in this part. Z bar, is it correct? Z bar, guys, check out. It should be 0.75. 3 by 4. Guys, check out. Is the Z bar correct? What is the Z bar? I think mistake with Z bar. What is the Z bar? It should not be 2 by 3 then. Centroid position is how much? It is 3 by 4. If I remember, it is 3 by 4. No, no, no. Problem is your centroid is... No, no, no. Is a smaller circle? Okay. Okay, okay. Let me check. The centroid is, yes, yes. Let me erase everything. Then it will be clear. So Z bar, okay, guys, no problem. Yeah, Z bar is, let's see the small, this, yeah, here, okay, I understood. So if answer, this is 5 by 11, only if, just a moment, no problem, guys, I got. So the answer is 1 by 2 if we take bigger boom, right? Okay, it is 1 by 2, okay, if you take middle boom is a bigger boom. But look here, let me erase and then see, because we have our right now see, yeah, it's a smaller boom, right? It's a smaller boom. Clear na, guys? Yeah, it's not bigger because we have done overwriting, okay, there. So when it okay, no problem. So again, if you write Z bar, so Z bar is what, guys? You should have notified, right, when I found the values. Okay, fine, no problem. Z bar is what? So again, if you write, it is what, 2 into point 2 into 2, then plus point 1 into 2, then plus 0.2 into not 0.2, it is 0.1. Middle boom is 0.1 into 2, then minus zero point 0.2 into 2, then it is 3 into zero point 0.2 plus 2 into zero point 0.1. Now is it clear, guys? Now is it clear? Yeah, thank you guys for correcting. So what is Z? It is Z bar 3 by 4. Then your ratio sigma x top upon sigma x bottom, and they ask determinant. So it is Z top upon Z bottom. It is 2 minus 3 by 4 upon minus 2 minus 3 by 4. So it will come as how much? 5 by 11. Okay. So everybody, it is clear. It is 5 by. I have written anything wrong? Okay. I have written twice. Yes. Yeah, yeah, got it. So that means, no, correct only, na? A. Where twice I have written? Where twice? Wait, wait, wait. What is the mistake? 2 into zero point 0.1, 3 booms, 3 into zero point 0.2, 2 into zero point 0.2 into 2. Here there is a 0. 0.2 into 0. Now it is correct. The middle boom, it is 0 point into 0. Okay. So guys, be careful. Silly mistakes. Okay. Guys, be careful. Silly mistakes. Okay. I need to be careful. You all also need to be careful. Silly mistake. Now it is 5 by 11. Okay. Answer is 5 by 11. Now somebody asked initially, right, how I have got from here to this. So guys, everybody clear now? 5 by 11, yes or no? 5 by 11 is the answer, yes or no? 5 by 11 is the answer. Okay. So now, okay. Look, guys, the cross section is symmetric, right? It's a symmetric about, it's a kind of T section. You guys can understand, right? It's a kind of T section. Yes or no, guys? So this T section is idealized in such a way. Here it's a bigger boom, okay, and here it's a bigger boom. Then there are two small booms, okay. Now tell me, guys, this T section. Who was asking na ki from initial explain? Who was that person? Yeah, Vignesh. You can see here. This is symmetric about what, Vignesh? This is symmetric about this axis, vertical axis, right? Z axis. So what is your IYZ? It is 0. Now in given problem, moment is given about only what? My. So what is your mz? mz is 0, right? So that means it's a simple bending about what? Y axis. So your sigma x is what? My upon Iyy into z. Now this z is measured from what? It is measured from centroid, right? And there is no requirement of finding cross sectional properties, right? Inertia, area moment of inertia. Why? Because they ask the ratio of what? Sigma top upon sigma x bottom magnitude. Clear na? Now Vignesh, and we know my centroid is not O, right? Why O is not centroid? Why O is not centroid? Can anyone tell? Why O is not centroid? Because this section is not symmetric about y axis, right? It is not, it is not symmetric about both axes, yes, or it is not symmetric about y axis also. Okay, so let's guys move to next question. Now Shivendra, this is your question where you talk na ki diagonal points are your maximum and minimum. But guys, again, people will do this also blindly. These questions also people do blindly, and they put anywhere, just find the final answer. We are not going to do that. Okay, so read this question. What is given? The maximum normal stress is asked for the thin-walled beam of square section of outer dimensions 120 by 120 and wall thickness 1 mm under the action of moment m naught equal to 96 Newton meter as shown in the figure is. Okay, you are not solved, no problem. But this is the case where you find the diagonal point. Why? Why? Because the moment about which you they given na the we have done na this, the moment about inclined axis, right? So this is what your m naught, and this alpha angle or theta is how much here? 45 degree. So now guys, tell me what will be your mx? Your mx is what? In this case, what is your mx? Mx is your m naught cos 45. What is your my? Minus m naught sin 45, right? Now guys, it's a square section, right? So what is your IXY? It's a symmetric. IXY is 0. What about your IXX? And IYY will be same, right? Because it's a square section, right? IXX and IYY will be same. Okay, I am not finding the value, that we can do later. Now guys, first thing, in this question, they ask what maximum normal stress. So where is the maximum normal stress? What we have discussed? This lies where? Furthest aft point from neutral axis. Yes or no, guys? Furthest aft point from neutral axis. Yes or no, right? It's not top fiber. How, I mean, top fiber or bottom happens only when what? Simple bending. Is it simple? They have given moment about inclined axis. So this is always furthest aft point from neutral axis. And that is applicable for simple bending also, right? Now guys, first thing here you find out neutral axis. So what is the neutral axis? Tan alpha. My tan alpha, what I found, it was K1 by K2. So what is your K1? K1 is My into Ixx upon Mx into Iyy, right? For symmetric cross section, yes or no, guys? So find out, guys, here Ixx and Iyy are same, and My and Mx, you guys can find out. What is the tan alpha coming? What is the tan alpha? It is coming as what? -1, right? Why -1? Because it is what? Minus m naught sine 45 upon m naught cos, right? Why, Ravi Teja, it is 1? It's -1, right? Again, you are doing wrong, Ravi. That's the mistake people do. Okay. So it is -1. Means what? Alpha is how much? -45. So if -45 means what? It is angle is what? What is neutral axis? Now tell me. Is it this or is it this? Which one? I will draw with two different color. This is the blue or orange. Which is your neutral axis? Blue is neutral axis, Vikas. Huh? Blue is neutral axis. What, man? When we took earlier, what was your alpha? This. When alpha is positive means it is a clockwise, right? Here alpha is coming negative means what? It should be anti-clockwise. It should be anti-clockwise, right? Yes or no? So what is your now? Tell me, guys. What is your neutral axis? Orange or blue? Everybody, orange or blue? It's orange, okay? So you all got neutral axis position, right? Now the second part, which is asked in the question. So all you got neutral axis. Okay, let me not rub here. Okay, I'll not rub. So you all got neutral axis, right? So neutral axis we got, this is my cross section, okay? And this is given, and what we found, neutral axis This is your neutral axis. Okay, so what is the furthest aft point from neutral axis now? Either this point or this point, right? Yes or no? So what is the coordinate? They given dimensions, right? 120 by 120, right? The outer dimensions are given. So what are the coordinate? If you take this coordinate, let's say 1, 2, 3, 4. So what are the coordinate? What is the one coordinate? 60 by 60. What is the 2 coordinate? 2, it is minus 60 by 60. What is the coordinate? 3, it is minus 60 comma minus 60. And what is the coordinate? 4, it is minus 60 comma minus 60, right? These are the coordinate. Now guys, write the bending stress formula for complex bending, right? Now this is complex bending or simple bending, guys? And tell me, it will be sigma z or sigma x? Now in this case, what it will be? It's a complex bending. It is sigma z, right? Because xy is your coordinate. So what is sigma z? It is m y upon I y plus into x plus m x upon ixx into y. Okay, now guys, in this problem you have to find at every point, right? And you guys can check. If you find sigma z1, can you guys tell me what will be your sigma z1? You guys can check it. Let's check it. What is your my? It is, before that, one thing is unknown here. What is, guys, unknown? This ixx and iyy is unknown, right? Area moment of inertia, it is unknown. Yes or no, guys? So you guys can find, right, area moment of inertia. Simple way can find, or using thin wall also we can find. Simple is what? What is this hollow section, right? So for hollow section, what will be the moment of inertia? First, outer dimension 120 power 4 by 12 minus, what is the inner dimension, guys? What is the inner dimension? 118, right? 118, Mr. Surendra, because thickness is 1 na, so both side 1 so it is 120 power 4 by 12 minus 118 power 4 by 12, right? This is how you can find inertia. I'll tell you thin wall also. Let's first finish this problem and then I will tell you how to find. So guys, find out this value. Find out this value, guys. How much this value, inertia value? It is 112, 35, 18. So 1.123518 10 to the power 6 we can write, right? Yeah. So it is 1.123518 into 10 to the power 6. Mm power, what is the mm power 4? Am I correct? Okay, so we know now inertia also, guys. Now your given moment is in what? Newton meter. What you are going to do, guys? Once your given moment is in Newton meter, what you guys are going to do? What you guys going? Newton mm. So make sure you change in Newton mm. Okay, that's good thing. Now guys, come back to next page. So what is your my? It is m naught what minus m naught sine 45 upon IY. Currently IXX and IYY value you guys don't submit. Okay, we can submit later. And what is your X coordinate for 0.6? It is 60. Then what is your MX? MX is M naught cos 45 upon IYY into 60. Now tell me guys, what is the value? At 1 what you are getting? When you substitute 0.1, what value you are getting? 0, right? So on neutral axis it should be 0, right? It's matching, yes or no guys? We found neutral axis at the blue line, right? Mathematically also you can see, right? So whatever we have found neutral axis correct, right? We can check here. Now guys, 0.2, right? Sigma 2, what it will be? It will be minus m naught sine 45 into, what is the value? X minus 60 upon IYY plus m naught cos 45 upon IYY into 60. Now these two will get added, right? Because this minus minus became plus. So you can write 2 into, what is the m naught value? Now I will substitute everything here. It is 96 into what? We have to convert to Newton mm, 10 to the power 3. Okay. Now what is this? 60 upon, we have written the inertia, right? Both IXX and IYY are same, right? So what is this value? Guys, I have written here both IYY. Okay, both are same. That's why IYY you can see. Okay, both are IYY because both are same. So twice. So we have written, and what is the value? Substitute, guys. It is 1.23518. So 1 and what is sine 45? Divide by under root 2. Under root 2 into 1 by under root 2, right? Sine 45 or cos 45, 1 by under root 2. So you have to divide, then 1.123518 into 10 to the power 6. So from here you will get your stress in what? Megapascal. It is in Newton per mm square. No, Vijay, you are wrong. You are getting 7 point, guys. Are you getting 7.25 Newton per mm square, right? So 1 Newton per mm square is what? 1 megapascal. So 7.25, okay, Newton per mm square, which is nothing but what? 7.25 megapascal, which is Newton per meter square. Clear na? So what is the answer, guys? Sigma Z2 will be your maximum bending stress, and it is 7.25. Now you guys can check sigma Z3, again it will come 0, and if you check sigma Z4, what it will come? Can anyone guess without writing? What will be sigma z for? It will be minus, it will be minus 7.25. It is minus 7.25. Same but minus. Clear now? So guys, now is it clear now? Everything about this complex bending, yes or no? Or unsymmetrical bending? What is neutral axis? Why stresses on neutral axis are zero? How we can check mathematically? How the bending, everything. Now guys, if you draw this, everybody, is it clear till here? Now guys, in this question, one more thing which you guys can see physically how the bending is happening. If you look this question, how the physically bending happening? Can anyone tell? The bending is happening like this. You guys are understanding? At 45 degree, it is getting bended. So on all the fibers which are lying here, you can say the which are lying here are in what? Tension, right? And the bottom fibers are in what? Compression. Above neutral axis, tension. Below neutral axis, compression. So now, is it bending is about x-axis or y-axis? I have written because both are same, na? Prujana. Ixx equal to Iyy in this case. Everybody, is it clear this question? Yes or no? Okay. Can I rub it? Yes. It is symmetric about both the axes, and Ixx equal to Iy because it's a square section. Moment is anti-clock. What it is anti-clock? Here there is nothing like anti-clock or the moment is like it is bending like this. Where it is anti-clock or clock, it is coming. It is not I am writing moment. I am writing this is bending. It's not moment. Okay. This I have shown now. It's a bending. Okay. Let me show the 3D view. So now guys, if you see the 3D view, let's draw first beam. So square beam. Okay. So square beam. So in this square beam, what they gave? They gave this is XY axis and they applied bending about this axis. Okay. Now we found this is what our neutral axis. Okay. So that means there is a bending moment which is bending like this. Clear? So it is bending about diagonal axis, not about x or you can say in simple word, it's a simple bending about diagonal axis. Clear my point? It's a simple bending about diagonal axis. Clear? This is what? Simple bending about what? Diagonal axis. Okay. So everybody, is it clear? 3D view. How this bending is happening? So here all the fiber which are here are under tension, and the diagonal below the diagonal, what all the points are there, these all are under compression. Okay, so can we move to next question, guys? Can we move to next question? Yes. Read this question, guys, what it says. The idealized cross section of a beam is comprised of four identical booms connected by shear webs. The beam is subjected to a bending moment M as shown in the figure. The inclination of the neutral axis to the x axis in degrees is, guys. So now, guys, tell me, this is which kind of cross section? Symmetric, non-symmetric, anti-symmetric, or what? It's an anti-symmetric cross section, right? So for anti-symmetric cross section, guys, we have seen this is what your neutral centroid, right? The point of anti-symmetry is what? Centroid, right? So one thing is not required to find in this problem is what? Centroid. So we know the point of anti-symmetry is what? Your centroid. Now, guys, in this given problem, what is your stress? If you take they ask only neutral axis. Okay, we are not worried about stress. Forget about stress. Now, what is your normal axis? What is your normal axis, guys? Z is your normal axis, right? Because x and y is your given coordinate. So what is your neutral axis position tan alpha? We can write tan alpha in terms of what? Moment and inertias, right? Now in this problem, what is your mx? What is your mx? What is given as mx? What is mx, guys? Quickly. It is given as m. What is your my? What is the my? My is 0. Good, guys. So what is your tan alpha? We know, right? Tan alpha is what? It is my into ixx minus mx into ix upon mx into iyy minus my into ixy, right? This formula we know, right? Yes or no, guys? This is the position of neutral axis tan alpha, right? Everybody, right? So in this problem, now substitute my is 0. So what will be your tan alpha? If you substitute my is 0, so what will be your tan alpha? Can anyone tell? It will be minus ixy upon iyy, right? Yes or no? So in this problem, what is the unknown? What is unknown? In this problem, what is unknown? You have to find what? What you need to find to solve this problem? What we need to find? Ixy and iyy, right? So guys, we can make a table, right? So there are how many booms? There are only 4 booms, right? So what is your iyy? What will be your iyy? If you take areas, so on boom area equal, right? all boom areas are seems to be equal. So I can write for top boom, right? It is 2 into A. What is the distance? It is A is the distance from centroid. The bottom boom, there are two boom, 1 and 2. So it is 2 into A. What is the distance? It is minus A from centroid. Right? No, sorry. This is IXX. We want IYY. This is not IXX, guys. Because, okay, guys, let me write first formula. Otherwise, it will be a big blunder. Okay. What is IYY? So, for boom IYY, we know, right? It is sigma AI into XI square, right? Better to write formula, guys. Otherwise, there will be a mistake. IYY is this, yes or no, guys? Quickly, right? Now, guys, do it. Now, AI. So, first boom is this. Okay, so what is the area? A. What is the XI distance from centroid? It is minus A square. Okay, then this boom, what is the area? A. What is the distance? 0. Then this boom, what is the area? A. What is the distance? 0. What is the last boom? A. What is the distance? Plus A square. Clear, guys? IYY. Is it clear? IYY calculation? Everybody, you guys can write in table form also. You guys can write in table form also, not an issue. Okay, one thing which we didn't do, getting the inertia using thin walled in last question, we will do after this. Okay, so this is IYY. So how much IYY is coming, guys? 2A square, yes or no? Now find out, guys, IXY. So guys, find out IXY. So this is my boom 1. So for my boom 1, what is the area? A. What is the XI distance? Minus A. What is the YI distance? It is A. Then second boom area A. What is the XI? 0. What is the YI? A. Then boom 3. What is the area? A. What is the distance? Xi 0, yi minus a, and then plus what is the area? A. What is the distance? Xi. What is the Xi distance? A. What is the yi distance? Minus a. So what is the IXY is coming, guys? Minus 2a square, right? It is minus 2a square. Now, guys, this value substitute here. What you are getting? Minus minus became plus, right? When you substitute IXY value, so here it is minus, then minus 2a square upon 2a square. So what you are getting? Tan alpha is how much? Tan alpha is how much? 1. So what is the alpha value then? 45. Now guys, you got positive. That means what? It is clockwise or anti-clockwise? Exactly. Clockwise from x-axis. So what is the neutral axis now? If you draw physically, what will be your neutral axis? This blue line or this orange line? Which is correct? Blue one is correct. So what it mean? What it mean, guys? This is correct. And one more thing I want to tell. If you find my bending stresses on this boom 1, what will be your sigma Z1 and Z4? Can anyone tell? What will be your sigma Z1 and Z4? These will be 0. These will be 0. So guys, can you do homework? Can you guys do homework? Guys, can you do homework? You guys find out on all 4 booms what are your bending stresses. Okay, that is your homework. Okay, what is the homework? In this question, find out sigma z at all the booms. You guys can do, yes or no? Sigma z2 will not be 0. Why it will be 0? Is it lying on neutral axis? Is this lying on neutral axis? Why it will be 0? It will not be. Only this is neutral axis. So here there is a distance, right? So non-zero. This is the distance non-zero. So one will be what? One will be compressive, one will be tensile. Okay? Now guys, I have found this inertia in what? Directly. I can find it in tabular form also. So it is better if you write inertia in a tabular form. If you want to write in tabular form what? It is a boom, then A, first ixx, right? So a I y I square, then a I x I square, and then a I x I y I, right? Now wait, there are boom 1, 2, 3, 4 boom. So first is not interested, we are not interested to find, but still we can write. So a, what is the y distance from here? It is a square, then a square, then it is a minus square, a minus square. Then second, what is area? A, what is xi distance? Minus a square, then a into 0 square, a into 0 square, then a into plus a square. Then you guys can write a into a minus a, then a into a 0, then a into minus. So guys, are you getting? No, we will not require to make table, but those who are finding it typical, they can make table. One thing lies, guys, I am telling, please avoid silly mistake. Understanding my point, the guys, many of you or including me, may know the concepts well, but should avoid mistakes. So to avoid mistakes, you should write all the steps, right? And after writing every steps, please keep checking, okay, and try to understand everything and write. See what you will start writing inertia. What usually you will do? You will write I equal to a y square, right? That is what our habit, right? Usually we find ixx, yes or no, guys? So quickly in hurry you will find a y square, but actually it is what required is what? Ixx, not ixx, right? It was iyy, right? It was iyy, right? So be careful. So this is the one thing you guys need to remember. Okay. So these questions, now some of the books, what they answer they give, what answer they are giving. Many people they are giving B as answer. So what is the answer, guys? If you know the concepts well, then only you can tell what is the answer. Clockwise 45 degrees is the answer. Clockwise 45 degrees is the answer. Yeah, this is 1, this is 2, this is 3, and this is 4. Guys, do it as a homework. Okay? 1, 2, 3, 4. 1, 2, 3, and 4. Okay? Now, one thing, as I told, we will do here, okay, is what? Finding inertia using thin-walled assumption. Okay, so this is what the section. Now in case of this, we know already, right? This is what your centroid. So guys, if you take inertia using, we want suppose ixx, right? So for this section ixx is directly, right? It's a bdq by 12, right? Because your x-axis is what? Your axis for this section and this section, right? Your centroidal axis is what? Again, the centroidal individual axis. So your ixx is here what? bdq by 12. Now guys, what is the b thickness here? 1. What is the height? 120 cube by 12. So this and this is done. Now for this and this, right, I can multiply 2. Now about its own axis, about its own axis, it is what? It is 120 into 1 cube by 12. So this need to be neglected from analysis. Then parallel axis theorem. What is the area? It is 120 into 1. Okay, and before that guys, you can further do thin walled this thin walled assumption we are not doing, because it's a outer dimensions. You have to do thin walled assumption also. So better you take exact. I will tell that thin walled assumption also. So it is what? 120 into 1 is what? Area, and then what is the distance? 60 is the distance, right, from centroid. So 60 square. You guys can find out. You will find this area moment of inertia is almost similar. Now guys, if you take thin walled, exactly thin walled assumption, okay, this is not exact, okay, these are approximate, okay. If you take exact thin walled assumption, outer dimension is 120, so mean line dimensions will be how much? Huh? It will be 119. Yes or no, guys? It will be 119. So my 1 into 119 mean line dimensions cube by 12. Then it will be what? 119 into 1. Then distance will be how much? 59.5 square. This is what? Using exact thin wall. Okay, and it has to be multiplied by 2. This will be multiplied by 2 because for bottom and top we are writing same. Why same? Because it is at equidistance and same area. Are you guys clear with this? Are you guys clear with this? Now tell me the answer. Using this, how much you got? Which was easier? This or that was easier? That was easier, right? The initially which we did, right, hollow one is easier, right? Not these many steps and complications. So what is the value? Ixx equal to Iyy using thin walled approximation. What is the value? What is the value, guys? Yeah. So it is closer by, right? 1.11, right? 49. Earlier we had 1.112. So if you use this value also, you can check it how much your stress is coming. So it is how much? 1.11494 into 10 to the power 6 power 4. Okay, so guys, check it. Guys, check out calculation and tell me how much sigma value we are getting using thin wall. What is the answer, guys? Approximately same. Okay, so read the question, guys. A thin-walled tube with external radius of 100 mm and wall thickness of 2 mm is fixed at one end, and it is subjected to a compressive load of 1 Newton acting at a point on the circumference parallel to its length, the maximum normal stress experienced by the structure. So was this question done by Rahul sir? Because it's a combined bending question, combined loading question. Was it done already? It is not done, no problem. We can do. So what is given? There is a thin walled tube. Okay. This is the thin walled tube. Okay. Fixed here. Now, what is there told? There is a 1 Newton acting on the circumference, okay, and it's a compressive load and parallel to its length. So, we know, right? Parallel to its length means parallel to axis. So, where is the axis of this tube? This is axis. Clear? Yes or no, guys? So this is how this is acting. They told external radius, right? So this external radius RE is how much? 100. And what is the thickness? It is 2 mm. Okay. So RE is 100 external. So what will be R median? What will be R median? Mean radius, guys. It's a thin walled structure. So what will be R mean? Thickness is 2. So R mean will be how much? It will be 99. Okay, fine. Now guys, the given load is not acting at the center, right? It is acting at what? Circumference. So what is going to happen, guys? Can anyone tell? We need to shift this load to center. Is it going to happen twist? Think of Mr. Amit, how the load is applied. Load is applied along the axis of the, it is along the length. it is applied along the length. It is not applied in cross section. It's applied along the length. So that means when we shift this load to center, it will be a moment, right? So what will be the moment? This will be the moment. So if you try to understand, there is one axial load and there will be a bending moment, right? Yes or no, guys? So what is the axial load? The P is 1 Newton, and what will be the bending moment? It will be 1 into R. R is how much? 100. So it is 1 Newton, 100 Newton mm. Clear, guys? Is this getting clear? When we shift this load is shifted on axis with a moment, because the load is applied along the length direction. So this is the length direction, guys. Try to visualize. You can say, if you take this, is the load is normal to this, not in the axis. It is not like this, it is not like this, or it is not like this. This is wrong, this is wrong. The load is acting normal to this. So when you shift this load from this point to this point, it will be shifted with that load along with the moment. Okay, so means this load when shifted here, this will be shifted with what? A load along with a moment. Okay, so like this will be the moment and the load is perpendicular to this. So you can say this moment. Okay, this is what the moment. Okay, clear? Everybody, is it clear? Yes or no? These two actions are happening. Now guys, what is next? They asked what? The maximum normal stress. The maximum normal stress. Okay, maximum normal stress. Okay, they ask the maximum normal stress experienced by the structure. Now guys, in this case, there are two kind of normal stresses. One will be sigma axial, which will be P by A. Right guys? Now what it will be P by A? Compressive or tensile? What is the P? It is 1. What is the area? What is this area of ring? What is the area of this ring? It will be 2 pi r mean into thickness, right? And it is the nature is what? Compressive. So compressive means I am drawing like this. The compressive. Now what about another normal stress, which will be bending? And sigma bending will be what? It will be m upon I into y, right? So what is the moment? It is 1 into 100 upon, what is the inertia for ring? Can anyone tell? What is the inertia of a ring? There are two way, right? Hollow or thin walled. So for thin walled, if you take Ixx equal to Iyy, and it will be 2 pi r cube t. That is what for ring, 2 pi r cube t. So it is what? 2 pi. What is the r? Mean cube by into t. And what is the y? Y is what? Your r external. Okay, now what will be the nature? How the variation will be happening, guys? See, on top it is compression and bottom it is what? On bottom it is what? Tension, right? Now guys, when you combine this final sigma normal, right, which is what? sigma A plus sigma bending. Where it is maximum? Tell me, guys. For this case, where it will be maximum? On top or bottom? Bottom it will be maximum. Think, Mr. Amit. What is the action for this combined loading? Where it is maximum? Top. Why it is on top? Because for top you can see in both the cases on top, what it is compressive, so both will get added. But if you take bottom, one is what? Tensile and another is what? Compressive. So summation will be less, right? One will be plus, one will be minus, so it is not max. So max will be on what? Top, right? So what is the value? You guys can say, find out, guys. Sigma A top and sigma B also top. Here, guys, it is bending. Okay, this is bending. Okay, so find out, guys. Now everything is known. I have already given what is the mean radius, what is the thickness, what is the external radius, and we have already converted everything in Newton mm. So find answer in megapascal. Find first answer, guys, in megapascal, and it will be negative. Why it will be negative? Because on top it is compressive. It is 2 pi r. It is ixx, na? It is 2 pi r cube t. 2 pi r cube t. 2 pi r cube t, na? For ring. It is from your engineering mechanics. Ixx equal to Iyy for a circular ring. It is 2 pi r cube t. Okay, so we can write here. Again, I'll write, I have the blank space. So sigma normal is what? Sigma axial plus sigma bending, and sigma axial 1 upon 2 pi r mean. So it is 99 into t plus. So 100 into 100 is what? External dimension, and 2 pi, it is 99 cube into t. T is how much? 2. Am I correct? Because it's a thin wall, na? Ravi Teja. Whenever they mention thin walled, right, this year also Ravi Teja, there was one question. If you use the thin walled assumption, then only your answer will be correct. Otherwise, your answer was not coming in range. Okay, you know, right? There is a GATE 2023 question. If you take R mean, then only your answer will be in range. So guys, find answer in megapascal because our dimensions are in Newton per mm. So guys, first find this, and then they asked answer in what? Kilopascal. So we will change that. And what? This is what? Negative we will get. These both are negative. Sign is very important, guys. In GATE exam, unless they say compressive stress, you have to put sign. If your stress is compressive, if they ask compressive stress or magnitude of stress, then only positive. Otherwise, if your stress is compressive, you have to put minus sign. Getting my point is clear, guys? So guys, find the answer. Yeah. First tell me answer in megapascal. So it will be minus 0.00242 megapascal, which is nothing but minus 2.42 kilo Pascal. Clear, guys? So this question is clear. Yes or no? So, guys, in simple bend, this is combined loading, right? In combined loading, you have to be more careful. There can be multiple action, and for that, if you refer my notes, IGC study material, my notes, I have given that all the different cases. Okay. Now, guys, further, if your load was like this, your load, axial load was outward, and your bend moment was like this. So where it will be maximum, guys, in this case? Where it will be maximum? It sigma bottom will be maximum. Good. Now, guys, another case. In this load like this, and it is given like this. Where it will be maximum? Sigma top will be maximum. Now, guys, another case. And in this case, if your bending is like this, where it is maximum and what it is? Where it is maximum and what it is? Compressive or tensile? Huh? Yes, it will be maximum, sigma bottom, and it will be compressive. What it is? Tensile or compressive? This is the case 2, case 3, and case 4. Case 1 is already asked. Case 3 is what? Tensile or compressive? And case 2 is tensile or compressive? Case 2 is tensile or compressive. We know maximum is at bottom. It is tensile or compressive, Shivendra Raj? Tensile, good. Case 3, Amit, tensile or compressive? Agam, Kore Lakshmi, Kalangi Praveen, and Kashyap, Nishant, Shivani, Vipin. Hmm? Tensile or compressive, case 3? See, think, and tell. Tensile, right? It is tensile. We can say This axial load will create tensile, and bending is what? It's a hogging bending. So on top it is tension. Here on bottom it is tension, and here it is compression. So that's all from today's class. So how was the class, guys?